Okay, so good afternoon, everyone. Today is the 15th session, and we are doing this right now. So, in the last session, we completed understanding the basics of NavMesh and how that helps us implement uh, AI, and how basically NavMesh is generally implementing AI and pathfinding, and what are the different parameters while generating a nav mesh, and what are the different parameters of a nav mesh agent. So we completed that part. Then we started with enemy AI, and we defined some parameters for the enemy AI, and then we started with the animations where we got stuck. So uh, that is where we'll continue from today. So this is where we left off last time. So what what I was doing wrong in the last session, where the zombie was not giving, like, not actually animating as it was supposed to. So if you remember, this is something similar to what we had last time, but I have changed it a bit. If you remember, in the last time, the conditions that we were adding, we were basically, I added a lot too many conditions on a single transition. So I was, is walking was false from idle to walk, but is attack was false. So that is a condition that I had made. So because too many conditions were being added, the transitions were not happening properly. So it was getting stuck at a single place. So what I've done now is I've changed those transitions. So just a quick recap: how do we get here? How do we have this? So we basically opened a window named as uh, animator controller. So animation is a different window, but we basically opened this. We created this thing, zombie anim controller, and this is the window that is open down here. So we opened it by creating a animator. So we have few options here for animator controller, animation, animator override controller. So we created an animator controller, and this is what our zombie anim controller is. And in this, what we did was we took some animations, which was attack, walk, and falling back. We took three animations right now from the asset pack that we had, zombie asset pack. So from here we took attack, walk, and falling back. So if you want to see those animations, you can come here and see those animations as well. This is what we saw last time as well. So these three animations we took, and now we want to implement them. So basically, this controller is responsible for controlling those animations, or basically defining the logic of how uh, different animations play with each other, or what are the conditions when uh, one animation should stop and the other animation should start playing. So we also took an idle animation here, uh, which, if you want to go here and see, this is the idle animation, which it's just standing and doing nothing. Then we define few parameters. So there are two windows here. In the parameters window, we defined three parameters. And in these parameters, we could have defined float, integer, boolean, and trigger. We used boolean and trigger. So we checked if the animation is, if the person or the character is walking, or is it attacking, or is it dead. And we'll set these triggers in the code, which we did. So if I go here, I was trying something, so I added this, but this, and we created an enemy AI script. So let me open this. So in this script, basically what we did was add an avmesh agent, a transform, which is a target where we are adding the player, and an animator. which will control the animations. In our start, we got all those things. In our update, we are checking the distance between the agent and the player. If that distance is greater than 2, then the animation that's supposed to be active is the walking animation. If that distance is not greater than 2, or which means it's less than 2, then the animation is supposed to be is attacking. And then this is the thing that is asking that's being used from the navmesh package, where basically we are asking the agent to we are setting a destination for the agent. So this is what we did last time. And basically after this, what I was making a mistake was this: I was in this transitions, I was adding another condition here: is attacking is false. So this was basically confusing our system. So I did this for all the transitions. I was adding a separate condition, which is not required. It is basically causing more confusion than anything. So for idle to walk, we just need is walking true. For walk back to idle, we want is walking false. From walk to attack, we want is attacking true. From attack to walk, we want is walking true. And then from attack to idle to attack directly would be is attacking true. Attack to idle back would be is attacking false. So this is when we enter. So this is the entry state. Entry state will by default go to an idle state. Idle state will rotate in this manner based on the triggers or the Boolean values that are being set from the code. And this is a separate condition where we have done any stage from any stage, if any state, if we activate this thing where basically is dead trigger is activated, then this will fall back and die. So these things we still have to implement in the code, which we haven't done yet. Now, where does this animator go? So this animator will go on my zombie, which is here. So animator I've assigned here. This is how it is being controlled. So one more thing that I changed is the default speed of an navmesh agent is 3.5 or 4 or something. So I had to reduce the speed of the agent to basically make it more like a zombie. So make it more slower, and that's all that's changed here. Other than that, everything is still the same. So this also added extra. Mm, The things are fine. So in our player, we added this. If you remember, in the player capsule, we added the tag player, which is how we are doing a lot of things. So now I can just go ahead and play, but I don't have a game tab, so I'll add that. So now if you see, the animations will be fine. So now the zombie is walking towards you and he's following you. And as soon as he comes towards you, he'll stop. So this is something that we can fix, and he starts attacking. Right now, as I said, we haven't added the code for the dead action. And the other thing that was happening is when it is in walk state, I think uh, it should directly go to the attack state, which is not happening, but we can figure that out sooner or later. It's basically coming back to idle and then going back to the uh, attack stage. So if we want to change that, then we can figure out some conditions here in the transitions. Then we can figure that out. But that is not important right now. We can deal with a bit of idle. So just to check, if I remove this for now, uh, this transition itself, I think right for now as a quick fix, this would be it. That if it comes from walk, it will straight away go to attack. Yeah, so this is a quick fix, but obviously we can figure out better way for doing the same thing later. So now what I want to do next is basically add the stopping distance we have changed. Now we'll add the death animation. So this thing we'll add in our enemy script. So what we'll do is we'll go to the, so we have another script which is controlling the health of the enemy. So this has to basically, this is where we are destroying the game object. So we have to make a play between this and the enemy AI. So these two scripts have to communicate with each other, and that is how basically we'll be able to destroy this. So what we can do here in this script is add a start function, and in this start function I can call I'll create a enemy AI object of that script, and in this I will just, because it is attached on the same object, game object, this is how we'll get it. And then in the enemy dead, all we need to do is enemy I. Oh, I don't think we have added a death enemy yet. Yeah, so I think we'll have to add that first, which is where exactly. Yeah, so here we'll add a new function, create public void enemy death animation, and in this all we need to do is anim dot set trigger, and the trigger name is dead. So here this is all we need to do. But how do we, when do we play this animation? When the health actually goes less than 0. So when is the health going to go less than 0? When this enemy dead function is being called. So all we do here is call that enemy AI dot enemy death animation. So that's it. But now if we go back, this will still not work very well for us, and we'll talk about why. So you see it disappears immediately. That is because the destroy game object runs right after this animation is called. So the game object is destroyed. So destroy basically has one overload available. Is if you want, you can give some time after which the asset should be removed. So I can give a 10-second time here, uh, so for which I want to remove this. Now this thing is running with me, and this thing I can just check here. I would want to not make it move with me. So for that, when the player is moving here, I can add a is dead check if it is not dead basically. So for that, what I can do is I can create a boolean is dead, and generally it will be false. This is where we set it to true, is dead equals true. And when we are actually moving the agent, we would want to check if it is not dead. So not is dead basically. So this way, when we kill the enemy, it will it should stop following us. So I hope this is clear. So if you, I'll just quickly, I think I did it too quick. So just as a recap, what we did was added a check in the movement script. So this is where basically it is, this is where it's moving, right? So this is how the nav mesh is helping our agent move. So what we did was apply a check that if the agent is dead, so for that we created a new bool. We set that as false by default, and when the enemy death animation actually plays, then the is dead is true. So when this becomes true, then this function won't run. So this thing will stop playing, right? So that is one thing that we had to do. And the next thing that we can do is basically if I go here again, in my enemy zombie, if I play, if you see the basically the enemy is not looking towards you, it's looking some random place, and let's say it starts attacking. If I go here, it's still attacking there. So this is something that is kind of breaking the illusion, right? So if I can, if this works, then I can just win the game whenever I want. So this is something that should not work. So for this, we'll add another condition. We'll add another check. So for that, we'll basically go to the here where in our else statement, because this is where the attacking is happening. So for walking, we can, it's fine. It is randomly looking here and there and walking. But for attacking, we want the player to look at us while attacking at least. So what we'll do is here we'll set up a uh, vector 3 direction, and this direction will be the target position minus transform position. So this will basically give us the direction between the two things, between the enemy and the, sorry, between the player and the enemy in a sense. And then what we want is to make the transform rotate. So transform dot rotation equals, this is quaternion. Quaternion basically, if you remember, I think we've talked about this before. They are used to represent rotations. So uh, they are what basically hold the rotation value. So we'll have quaternion dot slurp. Slurp will basically interpolate between two values. So the movement, the rotation will not be a sudden movement. It will basically be a small movement when we give it 2 points. It will be by some parameter change. We'll assign a change parameter, uh, like what value should the rotation happen by, and then we can use that. So slurp, and then we want to define transform dot rotation is our first quaternion. Quaternion dot, again, this is one more function that we are using. So quaternion dot look rotation. So look rotation will basically create a rotation in a specific direction. So look rotation. So this is what is basically actually doing the rotation. The slurp is basically being used to rotate it more smoothly. And these two places, like the current rotation and where it want to where do we want to rotate, is what we are rotating between. So here we'll give a direction, and then after the direction we'll have a let's say a value of 5, and we'll have to multiply this by time dot delta time like always. So this is something that we wanted to do. And now let's see how this works in the, okay, some error is there. Did we make some mistake here? Oh, forgot to add a semicolon. So now when we go towards the player, it will, right? So it is moving towards us, rotating towards the player and seeing the player. So one thing is that right now, because the distance between the player and the uh, enemy is very small, you are not able to see it. But generally, if you try this, there might be some issues in following the rotation of the x direction of the y-axis. So if you get too close to the enemy, because right now we have specified stopping distance and everything. So if you get too close to the enemy, it is still trying to look at you. So let's say your height is small, and it'll look at you like this. Or if your height is too big and if you get too close, it'll look at you like this. But we want the enemy to still look at you eye to eye or in your line of sight. So for that, what we can do is we can add one new thing here where we basically say direction dot y is 0. So don't change the direction along the x-axis of the enemy. So this is something that is not visible in the current scenario, but this might affect performance in some other scenarios. So this is something to keep in mind, that generally when you are on an XZ plane, uh, the rotation should take place on that plane only and not on the y-axis plane. So I think that's all for the enemy AI for now, in the sense that it is following the player, it is attacking the player, although nothing is happening right now because the player does not have a health component attached to it like the enemy has. So we come back to that and we attach that. So again, I'll do a quick recap of what we have achieved till now in this, because I think things might be moving too quickly. So if you have any doubt, you can ask. Otherwise, I'll do a quick recap of what we did to set up the enemy like this. So the very first thing that we did was basically set up a navigation area. So we set up a nav mesh inside our this inside our scene. So this is our nav mesh. So nav mesh is basically allowing us to move between to allowing us to move the agent from point A to point B by setting some destination. That destination for right now and in general, what we have set is the player's location. So generally, if when we got that, just a second. So generally, when we want, like when we have a bigger game, so this is a very small room. So generally, we might have a bigger environment, bigger game where we basically would uh, have, like, let's say multiple enemies set up, multiple enemies in each room. Then how will you tackle this problem where basically if you add nav mesh and you add target as player, then how would you tackle this problem, right? So there are certain ways of doing this. So there is one way of doing that is basically you define a distance from the player at which the enemy actually gets activated. Other than that, it's either playing some random animations if it is visible, or you can just not have it in the scene as well if it is not visible in the camera somehow. So depending upon what kind of a game is set up. So like let's say if there is a game where you or the player has access to CCTV footage or a drone or some kind of a camera where the player can go ahead and actually visualize the scene. So in those scenarios, the enemy should be present in the scene physically and should be looking around, doing some random uh, animations, right? Patrolling, things like that. But let's say in a scenario where it's like, for example, this room where if I want to set up an enemy in each room, two or three enemies in each room. So I don't need to necessarily have those enemy when the game starts, because the player has no way of seeing the enemies in the other. So what I can do is I can add a collider or a trigger right here. And when the player passes through this trigger, that is when the enemy in the other room get activated. And that is one step. The other step would be to basically add a distance thing, which we are already doing. So we are already calculating the distance between the player and the target, right? So for right now, we have kept is that when it is greater than 2, the enemy starts moving and all those things. But what we can do is also do one more condition. We can keep this moving distance as uh, greater than 2 and less than 5, and greater than 5 the enemy is not activated. So we can do something like that. Or depending upon uh, what the scenario is, what the distance between uh, the gate and the enemy, and the environment size, or the condition, or the complexity also that you want to make, you can change this value. So this is one part. So coming back to what we did actually, so we added the nav mesh, and then we basically added this uh, inside our enemy zombie, we added a nav mesh agent. In the nav mesh agent, we have some conditions in which we only change the speed for now. We can also change the angular speed as well. So the speed at which it rotates, uh, that again, depending upon how a zombie should behave, you can change those things. Acceleration can be changed, stopping distance can be changed. So stopping distance we have kept 2, because we here also have defined that if it is a greater distance than 2, it should start walking. Other than that, it's attacking. So if it's near the player, it's attacking basically. If it's not near the player, it's walking. Then other features that are here, which we have obstacle, we don't have any obstacles, but we can define those things as well. But these are the default settings that are there. And then we basically created a enemy AI script, in which we define some conditions, which is our script right here. This is the script in which we basically created an mesh agent, transform for the player target and animator. And then in the uh, agent, this is the only thing we are using for the agent in a sense, where basically we are setting the target position. And then for the animation, we are using the Boolean triggers in a sense, and we are actually using a trigger for the dead animation. Where are these being set? These are being set in the animator. How did we create the animator? We created the animator here, zombie anim controller. So animator controller is basically controlling how the animations logic happen. What are the conditions between which they uh, transfer from one animation to the other animation? And those conditions are basically entry. Whenever it starts from entry to idle, it will go automatically, and from idle to walk and then attack, these things will change based on certain conditions. So for idle to walk, the condition is that is walking should be true. For walk to attack, is attack should be true. For attack to idle, is attack should be false. So these things we have set. And next, for the trigger, what we said for the falling back trigger, so we said is dead trigger from any state. So it doesn't matter if you're in idle, if you're in walk, or if you're attack, this trigger will set from any state. And then basically uh, we the last thing that we did was attach a player health component with the player health component. We communicated between two scripts, enemy AI and enemy health. So in the health component, we basically saw whenever the health was going great less than 0, I think we can make it equal to 0 also. So less than equal to 0, it will basically trigger a death animation and destroy the object. So we are giving it 10 seconds to destroy the object. So this is something that we defined. And then finally, what we did was, because to make the enemy look at us while it is uh, attacking, we basically did this thing where if it is moving, if it is attacking, it basically looks at us. And I think we can do a similar thing for when it is walking as well if you want that it looks toward you, but that might be a bit weird based on the angles and stuff. So uh, you can try it out and see how that looks. All right. So I think this is where we are till now with the whole thing. So next thing that we want to do is if I go here, so we have completed enemy AI and animations. Now what we want to do is introduce player damage. So the player also should feel something inside the game. Also, she should have a consequence inside the game. So for that, we'll add player damage. Just a second. Now for player health, we will create a new script, which we do not have right now. This would be just a second. All right. So player health will be set up more or less similar to the enemy health. We'll define a specific health, maximum health, uh, like we did in this condition. And more or less, it's going to be the same thing. So let's do that quickly. So we'll set a public float current health. This is to monitor the actual health of the player. Then we'll have a max health, which will be set to 100 when it starts, just like similar to enemy health. And generally this would be a best way of doing anything. So like when you represent it to the player or the user, you don't actually use the values of 100 or 10 or 50, but you generally use a visual indication. So like a health bar or some kind of vignette on the screen where basically some like outer screen becomes red when the player's health is decreasing very much. So this is again your creativity in picture, like how can you do these things depending upon how much visual effects you can actually add to your scenarios. Depending upon scenarios also, like do you want to make it realistic or do you want to make it uh, towards the fantasy side? So depending on those things also, it depends how you want to animate these things or create these things. Then we'll have a start function here. In the start function, all we want to do is current health is equals to max health, because this we are doing is generally not required. Uh, but what if our player dies somewhere and we want to create uh, a spawning feature, so respawning feature, where we let's say we give the player 3 lives, so it can complete the whole game in 3 different tries. So what we want is because we'll just respawn the player, we'll not reload the whole scene. So this is important that the current health again becomes full, right? If it is 0, then how do you change that? So that, and next we'll have a public function that we had similar to the enemy health. So we had a damage function here, deduct health. So similarly, we'll have a function that we'll call from somewhere else, uh, most probably from the enemy AI. So we'll have a damage player, and in this we'll have a float damage, which can be defined somewhere else, like we did in the case of enemy health. And this, all we need to do here is current health minus equals to damage. So whenever this damage player function is called, this will basically reduce the damage, reduce the current health with some specific value. Next thing we want to do is basically create a singleton of the player. So singleton is basically a static uh, variable that we create inside the player health function, which can be used anywhere to basically access this function. So this is how we create a singleton. We'll have to create a public static and call it player health. We can call it an instance, or to make it straightforward, we can call it a singleton. And in an awake function, we just need to do singleton equals to this. So this script is the singleton player health that we'll use everywhere. So now where do we actually want to use this singleton and how do we want to damage it? Like I said, we'll be doing that from the enemy AI script. So inside the enemy AI script, we will create a new, uh, we'll create a few new functions like damage amount, which we have to do, public float damage amount. Let's set it to something like 30. We can come back and see how we want to change it or whatever. And we can also set one more thing here, which should be the attack time. So after how much time can it re-attack in a sense, right? So like we did with the rate of fire, this is similar to that. So in a sense, this is the rate of attack. So let's for now set it as 2f. Now what we want to do next is here in our else statement uh, where the attack is actually happening, we will set the okay. So what we are doing is we will for this whole thing we'll create a new coroutine, and in that coroutine is where all these things will happen. And in the coroutine, we'll set some things. So to do that, we will take one more thing. So basically to implement this thing properly, the tag time properly, we'll create a one more variable here, which will be a Boolean variable, public bool can attack. So we want to check if the enemy can attack the player or not, and this thing will change based on the attack time of 2 seconds. So here, what we'll do is if inside this, we will check uh, here we'll check else if we'll add instead of just else, we'll add if can attack. So what we are checking here is if this can attack is false or true. So sorry, this here should be true. So that is how it will be able to go in initially. So this is initially starting with a true value. Here we'll go in, and here we'll call a coroutine. So that coroutine will let's first define that coroutine. So if you remember, this is how we define a coroutine. Let's call it attack time or attack or whatever you want to call it, basically. And then as soon as we come inside, we can set the attack can attack to false. And then wait for some time, you'll yield return not null, new, wait for seconds, let's say 0.5 f. After this, we want to call the singleton. that we created. So player health dot singleton dot damage player, and in this we will give the damage amount. Once this happens, then we again want to wait for the attack time. So yield return, sorry, new, wait for seconds, damage, oh sorry, attack time. And once this has happened, we can go back to can attack equals to true. And here is where we call the yeah. So here is where we call the coroutine. So start coroutine. Great. So quick recap of what we did inside the player health. So this is the first thing that we created, player health. We defined a current health. We defined a max health. The current health is basically to keep track of what the current status of the player's health is. Then we defined in the start that the current health equals to max health, and then we create the function called damage player, which will be called whenever the player is being attacked. In this function is basically a damage will come from the function or the attacking function in a sense, and that damage is what we are minusing from the current health. And we'll come back and write the function and write the code to where actually we're checking if the player is dead or not, similar to what we did with the enemy. So we'll come back for that. And but what we did in the enemy AI, before that we created a singleton. So for creating a singleton, what we did was create a static variable of the player health itself. So there are obviously hundreds of different ways of accessing one uh, object's component in the other object, or this script in another script. But this is a new way of doing that. So we have not accessed it like this anywhere till now. So what we did was basically create a singleton of this script, which will basically hold all the current updated information and can be called just by using the player health dot instance, basically like a static variable can be called. And in the awake function, we basically define that this singleton is attached to this script. And in the enemy AI script, what we did was define three variables: a damage amount, an attack time, and a boolean to check if we can actually attack or not. So in the uh, attack code, we added an if statement there to check if the enemy can actually attack or not. This is basically to check to reduce the time of attack, to slow down the time of attack, because otherwise the player will be dead in minutes in just one instance, right? So what we want to do is basically reduce that time, and for that we checked if it can attack, and we added some delays. So we added a delay here of 0.5 seconds before calling this damage amount, and we added a delay for the attack time that we defined before. And then in this coroutine, we are first setting the can attack as false, and then doing these things, waiting, attacking, again waiting, then setting it to back again to can attack. And then we are calling this coroutine inside our attack time. So now let's go back and have a look at how things are. So I'll select, oh, I haven't attached the script to anything yet. So I will attach it here because this is where all the other scripts are. So this is where the shoot script is. This is where I'll also add the player health script. Okay. Well, oh, it's a prefab, so but doesn't matter. So this is how it's right now. And then when I go to play, So health is going down slowly. Now it's going in minus. So now we would want to basically stop when the health is at 0, and for now we'll just debug that at and later we can, when the player is dead, we can either add a respawn or we can add a uh, game over screen kind of a thing, right? So going back to our player health script, we will add a new function. We will call it public bool is dead. So we need to check if the player is dead or not, and we might want to use this somewhere else. That is why we are doing this as a variable. And then we would basically, inside the damage player itself, we will first check if the current health is greater than 0. Greater than equal to 0, we can make it. If the current health of the player is greater than equal to 0, then we can continue the damage. If not, else we can call a function called as dead. So just dead. And let's create that function here. Dead. And inside dead, what we want is that to set the current health equals to 0, because just in case it goes back to negative some value, we want to keep it at a 0 level. Then is dead equals to true, and then debug dot log player dead. And for now, we can also, if you destroy this object, then basically uh, we'll not be able to see anything inside the screen anymore. But we'll come back to this and uh, see what we want to do again at a later stage. So it's working, and but it's still, even after it's dead, this is still moving and it's still going on. So we can go here, and this is why we have this is dead value. We can go here and change that. Uh, we already have this, not dead. So this is for the enemy. So what we can do is, if the so what we can do is basically stop everything. If stop all the animations and everything, basically this whole calculation and all those things, if the player is dead, right? So to do that, uh, we can just put all of this inside if uh, we have player health dot singleton dot is dead. So we'll check for not. If not dead, then we are basically doing these things, all these things, which means that till the player is alive, we are doing these things. Once the player is dead, which means else, then we can basically stop the animations and everything. So how do we can do agent dot update position equals to false. This will stop the agent from moving. Then we can do anim dot set bool. So basically both these animations we can set to false. And that way we'll come back to the original thing that nothing will move. It will go back to an idle condition. And if we have multiple enemies, multiple non-playing characters, this will help us in saving resources once this is done. So once the player is dead, the animations and all stop. So also, if you want, you can destroy the game objects, everything like whatever you want to do after this, you can do. And that we are doing just through this thing. So we are setting it here in this else statement, whatever we want to do, or by checking this is singleton is dead. So basically, this is where we are defining that the player is dead. So whatever conditions, whatever scene transitions that you want to do, which we probably will look at, uh, and uh, those things can be controlled through is dead. So that is all I had prepared for today. I think we have completed both the things now. So enemy AI and animations are done and player damage is done. So next session we'll discuss maybe animating the uh, maybe adding the effects here. So maybe one or two more sessions dealing with a few more concepts around this thing. And after that, we'll start with as planned with the XR development. So in that, we'll look at the XR interaction toolkit and for specifically for VR, and then the AR foundation toolkit, which is specifically for AR. If- and I I think I was supposed to discuss in the last session with your coordinators about the availability of devices to you guys, which I was not able to do, which I will do now. And we'll see what uh, most most feasible plan would be. I think if availability of a VR device would be a problem, then we can have more sessions of AR, a few sessions of just setting up VR so that when you have time, you can test those things. So for VR, whatever we have done till now will work as is for VR. So most things, whatever we have done, you'll implement the same things in VR. All the concepts will work as is. So similarly for AR, all the concepts will work as is, but a few different concepts specifically pertaining to AR, uh, like detection of planes, detection of things in the environment, seeing those kind of things, that will be specific to AR. So maybe we can spend more time there rather than spending time with VR, which you can implement when you have access to the devices. And then lastly, again, like we talked before, some bonus sessions where we can discuss other utilities of Unity and some other uh, functions where you can learn creating uh, face masks or filters or whatever on Instagram if time permits. Otherwise, I'll share resources for those, and those are like very straightforward things. I'll maybe take a small session on that. I also don't do it much. I have not done it much. I did it as a trying testing things out once, so I have limited knowledge of that, but we can try it out. And that is all from my side. If you have any questions, you can ask now. Otherwise, we can end the session.
We just have to take a group pic.
Yeah, yeah, please go ahead.
So everyone, please switch on your camera.